Good morning, everyone. Alright, we are still in the exercise 3 parabola, but now we're going to describe 4 parameters, 4 specific points that you have to recognize and see for a parabola graph. Alright, so we have first the turning point, which is the most recognizable point in a parabola. So the turning point is the specific point where the parabola stop declining and start inclining. So where it changes the sign of the inclination. So here it's this specific point here. Stop declining, start inclining, just on the minimum point for this parabola. And you write a turning point on a graph with a cross for the point and an arrow, small arrow pointing right and left, saying at that specific point the gradient is 0. So here it's turning on the turning point there. And when you have the equation written as a bracket x minus p squared plus q, the turning point is very easy to find, as the x and y value of the turning point is the p value for x and the q value for y. So you just have to read from this equation. Be careful, the p is the opposite sign from the equation, so if you have a minus 2, then you have a 2 for p, and the q is the number on the right hand side, so if you have a minus 2 for q, it's a minus 2 for the y value of the turning point. Alright, very easy. Okay, then you have here the second thing you have to know, the x-intercept, or the roots, or the 0 points. 3 different names for the same thing. The x-intercept are the 0 points or the roots for a parabola. And the x-intercept is the point where the graph intersects the x-axis. So here, the x-intercept are the 2 points where the graph crosses the x-axis. And each point has a set of coordinates. So for this one, the x-intercept on the left-hand side has an x of minus 1, and obviously a y of 0. For the x-intercept, the y is always 0. And for the x-intercept on the right-hand side, the x value is here 2.5, and the y value is 0, because it's always 0 for y, for the x-intercept. Alright, so x-intercept, the points where the graph crosses the x-axis, you give the value for x, and it's always a 0 for y. Alright, for parabolas, there is 3 different options, because remember the last video, we said the graph can be shifted up or down with the q value. So if your q value shifted up above the x-axis, what happened to the x-intercept? Well, that parabola will maybe never cross the x-axis. Therefore, there will be no x-intercept. So there is 3 options. Like on the board here, if the graph crosses twice the x-axis, you got 2 solutions, 2 x-intercept, the positive and the negative one. It can happen that the graph is completely above the x-axis, then there is 0 solution, no x-intercept. This line is never going to be equal to 0. And there is a third solution where the shift is just enough for the graph to touch the x-axis, but not cross it twice, just touch it at one specific point, then you got only 1 solution. So there is 3 options for the x-intercept, or 2, like here, or 1 when it's only just touching once, or 0 if the graph is too high compared to the x-axis. The three options are possible and correct. Let's see here the two examples I gave you in the lesson. First example, we have this equation and we can see it's crossing twice the x-axis. We have the two roots or the two x-intercepts given here and there. But for the example 2, this equation, if I draw it, I'm going to get this graph, and what can we see? There is no x-intercept. The graph is too high, it's not going to cross. So you just write simply no x-intercept or no solution. Okay. Third thing, the y-intercept. So this one is where is the graph crossing the y-axis. So where does it cross the y-axis? Here. That's the y-intercept. So here, the value for the y-intercept is always 0 for x. Y-intercept 0 for x. And what's the y value? For here is minus 1.5. So here, on this graph, the y-intercept has 0 for x and minus 1.5 for y. Okay, to find the y-intercept, because it's always when x equals 0, you just substitute the x with a 0 and you calculate the value of the function. That's very simple. So for instance here, we add this equation, and I was not able to read on the graph precisely what was the value for y. So you substitute the x with 0, so that's 2 times 0 squared plus 3 times 0 plus 2, and that will give you 0 plus 0 plus 2, y equals 2. So the y-intercept for this equation, for this graph, is 0 for x, 2 for y, which is what we had on that graph here. Alright. Last thing. The fourth thing you have to know here is the axis of symmetry. So you must see that all parabolas have an axis of symmetry that crosses, that splits the parabola right in the center, and if you fold this side of the parabola on that side of the parabola, the two lines, the two halves of the graphs overlap perfectly. So where is the middle of this graph? Where is the axis of symmetry? Well, right in the center. And the center point of a parabola is the turning point. So here, the axis of symmetry is the vertical line here. And this vertical line has an equation as x equal the x value of the turning point, and the x value of the turning point is the p-value. So the axis of symmetry has the equation as x equal the p-value. Remember that p-value on your equation. So let's see. Here, with this parabola here, the axis of symmetry is going through the turning point. And the turning point has PQ, so the P is 2 and the Q is 6. So the turning point of this parabola is 2, 6, and we said the axis of symmetry as for equation x equals P, so then x equals 2. It goes through the x of the turning point. Alright? P is 2, so then x is 2. Right? So now you're going to try to apply that for homework, and you have an equation written as x minus p squared minus 4 or plus q, and here you have to sketch the graph and give the coordinates. So read on the graph, make sure, draw it precisely, use the table method, choose 5 different x's value, calculate the 5 y's, plot, and draw your parabola. Remember, it must be a parabola. If it's not, you have sign or calculation mistakes somewhere. And you give me the equation or the coordinates of turning points, x-intercept 1, 2, or 0, and y-intercept axis of symmetry. And then you go in your book 3.1 and 3.2. I give you here a bit of summary of previous works to help you with the 3.1 and 3.2 in the book. Alright, enjoy, bye bye.